Welcome to Class 10 Insight. In today's class, we shall be revising the chapter Electricity. It is done with the exam point of view. All the points which we are going to discuss today are very important. You can use this video during your revision time. What is an electric charge? A fundamental particle in an atom might be positive or negative. What are the properties of these charges? Like charges repel and unlike charges attract each other. The SI unit of this charge is coulomb, represented with letter C. Charge, that is 1 coulomb of charge. Charge is equal to how many number of electrons? This is a standard value you have to remember. That is 6 into 10 to the power 18 electrons. In 1 coulomb of charge, these many number of electrons will be there. So what is the charge of this one electron? We know that electron has negative charge. And what is the amount of charge each electron has? It is 1.6 into 10 to the power minus 19 coulomb. Q is equal to N into E, very important from examination point of view, which says that the total charge in any particle will be equal to number of electrons along with charge of one electron, which is nothing but 1.6 into 10 to the power minus 19 coulomb. Coming to the current. The flow of these charges itself, we call it as a electric current. The rate of flow of electric charges, rate means it is with respect to time. The rate of flow of electric charges, we call it as electric current. Electrons constitute the flow of charges. I is equal to Q by T. I is nothing but current. I is nothing but current, which is equal to Q by T. Q is representation of charge and T is with respect to time. So the amount of charge that is going to flow through a conductor in a given time, we call that as current. The SI unit of electric current is ampere. SI unit of electric charge is coulomb. SI unit of electric charge is coulomb and SI unit of electric current is ampere. We discussed about charge, 1 coulomb of charge. Now what is current and 1 ampere of current. What is 1 ampere of current? The current flowing through a conductor is said to be 1 ampere when it is constituted by the flow of 1 coulomb of charge per second. There is an instrument to measure what is the amount of current flowing through the conductor. It is ammeter. An instrument to measure electric current used to measure electric current in a circuit is known as ammeter. It has low resistance and it is always connected in series. Very important point, it is always connected in series. So you can observe here, we have an ammeter which measures the amount of current that is flowing through the circuit. It is always connected in series in the circuit. What is an electric circuit? A closed path along which the electric current is going to flow through. Potential difference. It is the amount of work done to move a unit charge. The amount of work done to move a unit charge from one point to another in an electric circuit is called a potential. Difference. It is the amount of work done to move a unit charge from one point to another is called as potential difference, represented with capital letter V. So, the SI unit of potential difference is volt. So, what is the potential difference? It is the amount of work done to move a unit charge. That is equal to work done by charge. Now, coming to what is 1 volt. So, when 1 joule of work is done in carrying 1 coulomb of charge, then the potential difference is called 1 volt. So, if you know the formula, you can easily write the definition. See, V is equal to W by Q. When will V be 1? When W is 1 and Q is also 1. So, what will the definition say? When 1 joule of work is done in carrying 1 coulomb of charge, then the potential difference will be 1 volt. So, V will be 1 when its right hand side both numerator and denominator are 1. This is how mathematically we can think. Coming to voltmeter, it is an instrument used to measure the potential difference. Voltmeter has high resistance and it is always connected in parallel. Just now we revised. Ammeter has got low resistance and it is connected in series, whereas voltmeter has got high resistance and it is connected in parallel. It is used to measure the potential difference across the circuit. Coming to a cell, it is the simplest device used to maintain the potential difference. Current always flows from higher potential to the lower potential. So this is the table from your textbook. You might be familiar. These are all the symbols for your electric components. So we can expect 1 or 2 mark question based on these symbols. So you have symbol for electric cell, battery, that is nothing but combination of cells, then plug key when it is opened and closed, and a wire joint. Wires crossing without joining, they are crossing each other, two wires, but they are not joining at any point. Electric bulb, resistance, rheostat or the variable resistance, two symbols are there, chances of asking MCQs. Then coming to the ammeter and voltmeter. This is used to measure the current and this is used to measure the potential difference. A very important law and expected question, Ohm's law. Ohm's law is going to give us the relationship between voltage and current. Potential difference across 2 points or a metallic conductor is directly proportional to the current passing through the circuit, provided the temperature remains constant. So what does the law? Ohm's law states that whatever would be the potential difference across 2 points, it is directly proportional to the amount of current that is flowing through the circuit. So in order to remove the proportionality, we can introduce a constant, nothing but R. So V is equal to I into R, where R is the resistance of the conductor which remains constant, which can be proved mathematically and graphically also. Experimentally, Ohm's law can be proved. So it gives us the relationship between potential difference and current. So what is this resistance? Resistance is the property of a conductor to resist the flow of charges through the circuit is called as resistance. What is the SI unit of resistance? It is ohm. Now what do we mean by 1 ohm? We know that V is equal to I into R. Keeping R here, if I take I to the other side, it becomes V divided by I. So when will R be 1? When both the numerator and the denominator are 1. That is, the potential difference across two ends of a conductor is 1 volt when the current through it is 1 ampere. When do we say the resistance of a conductor is 1 ohm? When R is equal to V by I, when V is 1 and I is 1. R is equal to V by I. When R is equal to V by I. When both the numerator and denominator is 1, then R is also 1. That is, the potential difference across two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance is said to be 1 ohm. We can see that from this relation R is equal to V by I, R and I are inversely proportional. We can see that they are inversely proportional. That is, if current increases, resistance decreases. In the same way, if the resistance is doubled, then the current gets halved. That is, if resistance is increased by 2 times, then current decreases by 2 times. Coming to the rheostat. Variable resistance is a component used to regulate current without changing the source of voltage. So it is used to regulate current according to the components we use used without changing the voltage. So what are the factors on which this resistance is going to depend? Resistance is directly proportional to the length of the conductor, that is L, inversely proportional to the area of cross section, that is capital A, directly proportional to the temperature, and it depends on the nature of the material. So which is the formula which relates that is R is directly proportional to length and inversely proportional to area of cross section. That is, if R is increased, length, that is, if length is increased, then resistance also increases. But if we increase the area of cross section, resistance decreases. That is, it is inversely proportional. So that is, R is directly proportional to length and inversely proportional to area of cross section. In order to remove this proportionality, we can introduce a proportionality constant called as rho by introducing an equal to sign. L by A remains the same. This rho, we call it as a constant of proportionality. So resistance, it also depends on the nature of the material. So it depends on what type of material it is. Based on that, the resistance will change, and it is directly proportional to the temperature also. A current flows easily through a thick wire than a thin wire. What is the reason? So it is an expected question. Thick wire will have area of cross section will be more. Area of cross section will be more, whereas in a thin wire, area of cross section will be less. So if area of cross section is more, resistance will be less. As a result, current can easily flow through a thick wire. Thick wire has larger area of cross section, hence resistance is less and flow of current is easier. Coming to resistivity. The resistance offered by a cube of material of side 1 meter when current flows perpendicular to its opposite faces. The SI unit of resistivity is ohm meter. The effective resistance is maximum when the resistors are connected in series, because the effective resistance, we take it as the sum of individual resistors. Two or more resistors are connected end to end. The arrangement is called series combination. In a series combination of resistors, the current is same in every part of the circuit. So the formula to find the effective resistance when the resistors are connected in series is R1 plus R2 plus R3. The effective resistance to be calculated when the resistors are connected in parallel. It can be observed here that the three resistors are connected in parallel. This is parallel combination. The effective resistance in parallel combination will be the least, that is the minimum resistance value we are going to get. So the resistance is highest in series, effective resistance is highest in series, and it is least or minimum when they are connected in parallel. We can observe an voltmeter is connected in parallel and the ammeter is connected in series. So the voltage across each resistor is same and equal to the applied voltage. In series, the value of each resistance is same, whereas when they are connected in parallel, voltage across each resistor is same and equal. So what are the advantages of using parallel combination over series combination? In a series circuit, the current is constant throughout the circuit. When one component fails, then the circuit is broken, which will not allow the current to pass through them. Hence, none of the components are going to work. For example, you would have seen serial lamps, that is nothing but the serial lights called as fairy lights. When each light is connected to the other light, suppose we have many lights like this, in between this light doesn't work, it will not allow the current to pass through the other lamps also, because in series circuit, if it is broken here, the circuit is broken here, it will not allow the current to pass through. But it doesn't happen in parallel. Different appliances have different requirements of current. This cannot be satisfied in series because current remains same. So when different appliances need different values of current, a different amount of current, we have to use parallel combination of resistors. The total resistance in a parallel circuit is decreased. That is, it is the least value you will be getting. This is very important. Heating effect of electric current. In an electric circuit, if an electric circuit is purely resistive, the source of energy continually get dissipated. Example, electric iron and electric heater. Power is equal to V into Q divided by T. That is, power is equal to potential difference into charge divided by time. Heat produced in time, H is equal to VIT. V is nothing but the voltage, that is nothing but the potential difference. I is the amount of current flowing through the given time. Coming to Joule's law of heating, this is also one of the important last expected question. H is equal to I square RT. Joule's law of heating, we know that the amount of current flowing through the conductor is going to give an heating effect, which is equal to square of current multiplied by the resistance of the conductor and the time during which that current is going to flow through. This relation, we call it as Joule's law of heating. Many equipments work on this. Previously, we have learned that H is equal to VI into T. Using Ohm's law, V is equal to I into R. V is equal to I into R. On substituting IR in place of V, we will be getting it as I square RT. That is Joule's law of heating. It is directly proportional to the square of the current, proportional to the resistance of the given current, and it is directly proportional to the time for which the current is going to flow through the conductor. Electric power. Numericals can be expected on this concept. These three formulas are very important. The rate of consumption of energy in an electrical appliance, we call it as electric power. The SI unit of electric power is watt. 1 watt is the power consumed by a device that carries 1 ampere of current at a potential difference of 1 volt. So, which is the formula which gives us this definition? It is P is equal to V into I. When do we say that P is 1? When V is 1 and current is also 1. That exactly is the definition. There is one more relation for electric power, that is P is equal to I square R and P is equal to V square by R. Next, coming to kilowatt hour, this is the commercial unit of energy which is used in daily life for calculating the amount of energy that is being used. So, kilowatt hour. So, the commercial unit of electrical energy is kilowatt hour. Kilo means 1000. 1 hour, it is equal to how many seconds? It is 3600 seconds. So, on shifting the decimal points, we have 5 points. After that, shifting it one place to the left, we can raise 10 to the power of 6 watt second, which is nothing but in joules. And this is a very important formula from numericals point of view. The energy consumed is equal to power into time. What are the practical application of Joule's law of heating? Heating effect of electric current has many useful applications. So, the electric press or the electric laundry iron, electric oven, electric toasters, kettle and electric heater, all of these work on the principle of Joule's law of heating. An electric bulb. Electric heating is used to produce light in an electric bulb. It gets very hot and emits light. A strong metal with high melting point doesn't oxidize, is used as a filament in bulb. That is nothing but tungsten is being used in electric bulb, which also works on Joule's law of heating. For MCQs, we can expect one question from tungsten. So, it has got high melting point. The bulbs filled with chemically inactive nitrogen, argon gases are used to prolong the life of the filament. The power consumed appears as heat and small part of light. Coming to electric fuse, important for 1 mark or 2 mark. It is a safety device that protects our electrical appliances in case of short circuit or overloading. Fuse protects circuits and appliances by stopping the flow of any unduly high electric current. The fuse is placed in series with the device. It is an alloy of aluminum, copper, iron, lead, etc. It has appropriate melting point because it has to melt before the current is going to reach the appliance. Hence, it has got appropriate melting point. The larger current melts the fuse wire and breaks the circuit as temperature increases, so saving the gadget. So, it is going to be used as a safety device.